Very good evening, good afternoon, guys. How are you doing? I hope I'm audible.
Good afternoon, sir.
Yes, sir. Good afternoon, sir.
Good
Audible,
afternoon,
sir.
good afternoon, guys. Okay, we will start with our steering gear circuits and then everything that is remaining. We will be doing the following things today. We will be covering hunting gear. Uh, then I'm thinking of talking about the torque motor right now, or we can actually talk about the torque motor when we actually look at the circuit of the steering gear circuit with the new ones. Okay, we will see that. Then we'll talk about the power units. That means we'll talk about the RAM type steering gear, the actuator type steering gear, the rotary vane steering gear, the Leonard system, which is a electrical steering gear. Okay, and then we'll also talk about the actual circuits. Means the different circuits of steering gears. We'll see some actual things from the manuals. We look at them. Then we can actually also talk about different constructions of both the type of steering gears, how they are made, a ram and as well as a rotary vane. Actuator type is not there for larger vessels, so we can just talk about it in a brief, but not too much. Similar with what the is not yet not there anymore in the uh, you know marine field. It is there as it is means it is there as in the historical books, but it is not that advantageous nowadays. So they have replaced it with the hydraulic type of steering gears only. Then we will also talk about the construction of all the steering gears and how they are made, different parts of it. We'll also talk about mechanical advantage. What exactly is mechanical advantage? We'll see at the uh, what is the mechanical advantage for different types of steering gears. We will compare between RAM, actuator, and rotary vane, and we'll see which is the most, we would say, most highly efficient amongst all the three and why. We look at some reasons for the same. Okay. Just give me a second. I'll start. Just give me a second. All right. So let's talk about our hunting gear first. Okay, it was pending in the last lecture. All right. Just give me a second. So first, I came across a better image of your ratchet and ball arrangement for the non-rotational this thing. That means for the standby pump not motoring, I just found a better diagram of it. So this is a better diagram. This is exactly how it looks like, and this is exactly how the entire arrangement is. The coupling is there, and on one side of the coupling, there is another flange which is covering the entire arrangement, and over there, that is arranged are these pawls, as you see here. This is the pawls over here. Okay, this is the pawls over here, and this is the ratchet mechanism which is in the center. Okay, which is stationary. Okay, and that is stationary, and the pawls are moving. This is the entire thing is connected to the foundation, as you see here. So this is the stationary pawls and the stationary ratchet, sorry, and the pawl is which is going to be moving along with the. This is the center which is showing here. This is the pawl up here. Okay, a better image, so I thought I share with you. Okay. Now let's talk about our hunting gear, the control mechanism for the hunting gear. What exactly are the different, when I say talk about the hunting gear, what exactly do I mean? So here you had seen this one small diagram, which I just showed the entire telemotor receiver, and this exactly was told as a hunting gear. All right. This was a hunting gear, and there was a ram and cylinder that is connected to the tiller, and directly it was actuating up and down, and that was what is giving the actuation. Now, if I want to talk about in depth about the hunting mechanism, there is a floating lever movement, okay, which put to the left pulls the pump control lever, and to the also to the left with the pivoting takes place at the bottom point. See what I'm talking about. When the tiller arm turns, it pushes the hunting link to the right, and which in turn pushes the pump control lever inwards and to the midship position, with pivoting action takes place at the top point. At the mid position, there is no stroke. I just read through it, then I will show what I'm talking about. Thus, the rudder actuation is stopped at the helm angle. For the rudder to be brought to the midship position, a telemotor receiver cylinder will have to be moved to the left and floating lever to the right, and pushing the pump control lever further in. The pump will start and the tiller will move in the opposite direction, pulling the hunting lever to the left. This will in turn pull the control lever pump back to the outward position and pivoting about the top floating lever point. Now, the telemotor receiver removes the position to indicate the bridge and requires the rudder to be moved. In order to move the rudder, the pump must be put on stroke, but the pump must be taken off stroke as soon as the desired position is reached. That means as soon as the desired angle of uh, the rudder is reached, the pump should be stopped. Now, without the telemotor moving again, the telemotor should still be there as long as it has not been reached. Okay. Now, in order to achieve this, the floating lever, commonly called as a hunting gear, is used. A buffer spring is fitted between the tiller arm and the floating lever to prevent damage to the ram shaft and the reef valve. The floating lever is attached to three places: the outer edge of the rudder stop, the pump stroke control lever, and the telemotor receiving cylinders. Now, this is the entire thing. You've got diagram 1, diagram 2, diagram 3. So diagram 1 is the neutral position where the rudder stop one end is connected to the floating lever. This entire thing is the floating lever. This vertical one is connected to the telemotor. This is called the telemotor lever. This vertical one is called as the pump control lever. Okay. So basically, when either of the two moves, that is either the rudder stop tiller moves, and it will transmit the movement to the floating lever. At one time, either of these points, that means A, if I name the points A, B, and C, they either of them will be acting like a pivot mechanism. Okay. So see what happens is, suppose this is a neutral position stroke when there is no suction, there is no discharge of the pump control lever. So if you take a Halisha pump or a radial piston pump, there will be one position where there will be no discharge. The stroke will be neutral, means it will not be going into the either sides of the discharge because of uh, the the rams or the pistons will not be generating any pressure. Okay, so this pump control lever will be is connected to that floating ring in that, say, in your Halisha pump, okay, and that is moving that entire floating ring and moving along with it, ठीक है. तो ये आपका जो चीज है, ये जो फ्लोटिंग लीवर के साथ में पंप कंट्रोल लीवर इज कनेक्टेड टू दैट, ठीक है. सो नाउ व्हाट हैपेंस इज, सपोज the attached from the telemotor, it gives one signal, say port or starboard, whatever it be. Now that will pull or push depending on the orientation, which direction you want to give. So in this case, it is showing into the pulling action. So maybe it is going to port side or starboard side. We don't know. It's not mentioned here. So it goes up. The telemotor signal is being taken up by the telemotor, which we studied before, and that is connected to this piston and a cylinder, which is being pulled up. Now, as this pulls up, at that particular moment, initially, suppose if I name these points, okay, this is better. This is a better one where you have actually named these three directions. Okay. So see again, this is the neutral position, the floating river which is in the horizontal state. Now this is stored in the vertical state like this. This is the R is connected to the receiver, P is to the pump control lever, and T is coming from the killer arm. The same thing in the line diagram is being represented. The three things same shown in the line diagram. So now suppose from the normal position from R, the receiver gives the action to push the entire floating lever. At that time, the tiller arm feedback link is at constant position, and that acts like a fulcrum, pulling the pump control lever to stroke. Okay, it will pull the pump control lever to, say, from P to P dash. So suppose this was the P position, P to P dash it comes. All right. At that time, R to R dash is what is the desired movement for the telemotor receiver. Okay, the telemotor receiver gives to R dash, and now the pump control lever moves from P to P dash. As you see here, also the pump control lever is moved up. Okay, from one position to just come up. At that time, this point acts like a fulcrum. It means a point around which it articulates. All right. Now, as the rudder moves, okay, what will happen is that now the rudder will start moving. That is, the rudder will start getting the angle which is desired. So as it does, this rudder will start tilting, and as it does, this connected lever to the rudder stalk, this will now start pushing it downwards. They will start pushing the floating lever downwards, as you see here. It will start pushing it downwards, and then at that time, this will move from T to T dash. All right, and in doing so, what happens is the entire floating lever is first horizontally pushed down because of this pressure coming from the feedback lever from the rudder stalk, and now the pump control lever which had moved from P to P dash, that subsequently comes back to P, and now point P acts like a fulcrum point. All right, act like a fulcrum point, and now as this rudder, there is a spring connected to this side as well as a spring in this side. Now as the pump control lever is of off stroke, all right, provided the telemotor is again got to zero, all right, this will then come back to neutral position. Means if it comes as long as the telemotor stroke is held to the desired angle, it will still stay there. All right. But the pump control lever has gone to zero. But now if the telemotor is got to zero, then the spring will push the floating lever back to the horizontal position, as you see here. Right. That is the basic action. So as it says, at one point the point T acts like a fulcrum. Then as it starts moving, the feedback lever starts pushing from T to T dash, and then after a particular point, point P acts like a fulcrum. All right, and now it will stay at this position as long as the telemotor receiver is at that position. All right. Now you want to go back to midship position. Okay. So when you go back to midship, all right, what is happening is now you take the rudder to midship position. All right. As soon as that happens, okay, right? See, I will just read this again from here because I believe you might get confused in this sense. Okay? So diagram one, in this diagram, the steering gear is in neutral position, pump off stroke, and the rudder is ready to at position as you see here. Diagram one. Diagram two, the diagram in the bridge order has been received and telemotor receiver is moved by floating lever. The floating lever will pivot about this end that is attached to the rudder stalk. By pivoting the floating lever, it will move the pump control lever and put the pump on stroke, and the oil will be supplied to steering gear. Now the pump is on stroke from P to P dash, and oil supplied to steering gear. Right. Now diagram 3, that means the oil is supplied to steering gear from the pump as I have now moved the rudder to the desired position. That means whatever the maximum angle in whichever direction. As the rudder turns, the floating lever is moved. This time it will pivot about the fixed end of the telemotor. This one, all right, the fixed end of the telemotor, and it moves and comes to over here. Okay. And as the floating lever moved by the rudder stalk, the pump control lever is also moved and acts to take the pump off stroke. Means again comes from P dash to P. In the diagram, the pump is now off stroke and the rudder will have stopped moving. So rudder will have stopped moving. It will be at that desired position at whatever angle it is given. Means if it is given at 20 degrees the port or starboard, it will stay at this position with the pump being off stroke. Okay. Now, this is again one more diagram of the same thing. Uh, just give me a second. Okay, sorry about that. This thing is not yet recovered fully. Anyways, now the rudder tails the feedback from T to T dash and the pump control is 0. Pumping stops and the rudder is at stops at starboard position. Okay. Now the wheel is brought to midships, the receiver midships, and the pump control levers moves to P, pivoting about point T, and the pumping starts again in reverse direction and pushes the ram to the right and the rudder turns portward. Means here now you want to leave at this position, okay, but the rudder will always be at this position. Now in this diagram, what is happening is now you want to get it back to midship positions. So now from R, the pump control lever, the telemotor receiver pushes this entire pin to R position. All right. And as soon as that occurs, okay, the pump will start again pivoting around the point R and now move the pump control lever from P to P dash. All right. And all right, pivoting about and the pump starts again to reverse direction. The pump goes in the opposite direction. Okay. Well, earlier the pump had gone in the say starboard direction and it was giving the starboard thrust. Now the pump is going to go from P to P double dash. Okay, in the port direction. And now again we to come back to midship, it is to give the other direction. And now ultimately, once this is achieved, okay, again at that point number P will act like a fulcrum, all right, and at that will again come back to zero thrust. Okay. And then again the same floating lever will come back to the same position. That means they've shown the both directions, means starting from the neutral position, coming back to neutral position, going to starboard, then again the pump is going to port and it will again got the entire floating lever back to zero position. Okay. But now again, if you want to go to again port on the other side, you have to give the again the movement on the other side, as you saw here. That means again automatically it will not start ultimately you until your this thing is moved. Now you see there is a buffer spring put over here. Okay. Uh, buffer spring put over here. We just see this action of this buffer spring also. Now see, the same thing we just see in this other diagram because this is a standardized diagram because this is there in I think to McJoy. This one is something which might be new to you guys because you might have not seen it before. But it's the same diagram in the same format which is shown there. But now you have the same thing over here in one line diagram. Now telemotor moves the floating lever from A to A dash. Okay, from A to A dash the telemotor moves that moves your entire thing for the A to A dash. C remains fixed. Okay, point C remains fixed, and B to B dash the stroke is given. The variable delivery form. The floating lever, the pump moves from B to B dash, and the hydraulics in the pump and pressurized system moving the rudder. As the rudder moves from A1 becomes a fixed end. Okay, as the rudder moves, A1 becomes the fixed end around which it pivots, and the floating river moves from C to C1. The floating river moves from C to C1. Okay, as the rudder moves, because the rudder action is now moving from C to C1. Okay. Now, this process brings the pump rod control back to the hydraulic no hydraulic position B. Again, from C to C1 it moves. At that time, B1 to B again have to touch. Okay. Now the rudder is now requested position E to A1, C to C1. That means again, if you want to go back to neutral position, you have to give the other motor receiver. So that now it will always remain at this position until this rudder has been got back to midship position. So when you get back to midship position, the motor will have to move here, okay, and then your pump will go in the other stroke, okay, and change as you saw the other diagram that way. Okay. See that the buffer spring in the hunting gear is provided to take up any excess movement beyond the maximum stroke of the pump. The extra movement is stored in the compressed spring and used to reset itself as the hunting gear approaches the no effect point. It also takes the effect of the heavy seat on the rudder. That means in case a heavy seat is there, this buffer spring also acts to minimize that. As well as it is approaching back the neutral position, it will just affect that faster. But ultimately, you will have to move the variable delivery pump back in the opposite direction as you see here to get the midship position. Otherwise, the rudder will always be locked in that position. Okay, rudder will not come back on its own until the motor is brought to zero. Means and you go back to the midship position. That will again affect the movement from T1 to T and bring the pump stroke back to zero. And ultimately, it will again come back to the same position. That means until and unless you give the opposite stroke of the pump, the movement of the rudder will not take place back to the zero position. And if you want to give more movement in the opposite direction, the rudder will have to be continued further until the desired direction again moves the rudder in the opposite direction. Okay. Back like this as you saw here. Okay. So rudder movement is controlled by the telemotor, and telemotor controls the hunting gear, and hunting gear effectively controls this entire operation. Okay, so this hunting gear operation and everything was there till many quite a few times. मतलब काफी साल तक ये चल रहा था, but nowadays this type of thing is no longer there. You do not have these hunting gear and floating lever and everything. Okay, so this is how the entire thing actually looks like in a control circuit parameter base. Okay, so here you have the uh, killer arm connected to the the buffer spring and connected to the floating lever. Okay, and directly to the connected to the floating lever is the pump. So if there are two pumps, there will be one connected to one pump and another one connected to other pump also. Okay, so that, and there is that anti-motoring operation which does not allow the other pump to start. Okay, because of that hydraulic wall there, or that anti-motoring mechanical ratchet and ball which you just saw. Okay, so the other pump will also be connected to the other side to the same floating lever. Okay, and or you have two floating levers, two what you call control levers like this. So one control lever on one side, one control lever on the other side, and both pumps either side. This one is coming from the telemotor, but you see here is the telemotor on the receiver on the top end, and this is the pin which is coming. Again, a fulcrum is there over here, and that is to the that receiver point, which was R. We saw that. So this is R over here. This is the C, and this is the killer connection. Okay. So ये ऐसा है. And now what you also have here is a hand wheel control position, which we'll see later on when we talk about emergency control. But this emergency control is no longer in control as long as the telemotor is there. It is just moving in and out. Okay, so you have to actually remove these pins and connect the pin dotted here. You connect the pin to the emergency side, and then only your emergency control mechanism, whatever it may be, will come into control. This is there inside the steering gear room itself. Okay. So this is also in the steering gear. This is also in the steering gear. This is coming from the bridge. This is coming from the local maneuvering emergency control. Okay. So if you have to remove the pin and place it here, then only the emergency control will come into operation. Otherwise, only the telemotor is operating, and that is operating through this fulcrum and controlling this entire thing. So you see, there are a lot of moving parts. You have got uh, one what you call pin over here. You have got lot of joints over here. So this was mechanism was highly unreliable because the problem was that this mechanism would lead to mechanical wear down of all these pins. This buffer spring used to break sometimes. This control lever used to also maybe get jammed because if it is not lubricated properly. This entire thing, was inside a small casing, which was effectively placed inside oil, so that you do not have the entire thing, being operating very smoothly. So if the oil used to leak out from the casing, then this used to get affected by frictional wear and other problems. So over the years, they have modified the systems. Okay. So earlier, what they used to do that they removed the telemotor and receiver, and they controlled it by electronic control, as we saw previously. We've seen that electronic rheostat type of control, and they had a hydraulic arm connected to that. So that was also a modification that from the entire telemotor, you're just replacing part of the systems, and you are getting away with your control system. That means you are able to operate the system effectively even without a completely hydraulic circuit. That means purely hydraulic controls are not. Some of part of they were electronics. But nowadays, what is happening is that they've removed all these parts. So the entire hunting lever is and all this thing is removed and been replaced by something called as a um, torque motor. Okay, so this torque motor is independent system, which is, as I said, this floating lever used to control both the pumps together. So if there was a problem in this floating lever itself, then both the pumps would not be operational. And even for the emergency control, hand control, you required this entire floating lever to work. So this is one mechanism which could fail and lead to the entire system which was not being operational. So they have replaced this thing by an independent system, which is called as a torque motor. So torque motor is a electronic control system which directly controls individual motors. That means for individual pumps, sorry, not motors. Individual pumps will have individual torque motors, and they will be directly controlled from the bridge. We will see how that happens. And this mechanism is outdated. This hunting gear and everything. Recently, they've started asking about torque motors also, but they also ask about hunting lever, hunting gear, and everything. Although this thing is not no longer there because it's unreliable. Okay, to say the least. So we will see the top motor right now. Just give me a second. All right. Uh, we will see this electrical control system, but we will also see later on, once we finish all the power units, we'll see the non-follow follow-up control systems. Okay, just give me a second. So once we see that non-follow-up control systems, we further talk about the control mechanisms for electronic controls and hydraulic controls over there also. But here we'll just see, because we are talking about torque motor, we will see how the entire system is there. This is a flow chart for the entire system, that how the thing is there. There is something called as a Jenny pump here. Okay, this Jenny pump is a type of a radial piston pump only. It is a proprietary thing of Mitsubishi. So they've come up with this name of a type of pump. Okay, so basically, see what is the control system is there. Here is a steering stand on the bridge. Okay, and here is a control box, and the control box gives the output into the stoke motor. Now, the stock motor is a component which is there inside the steering compartment itself, mounted onto the hydraulic reservoir. Okay, and as the torque motor operates, it will give the feedback back to the bridge. Okay, That means as the if the torque motor has started to operate, it means whatever signal you have given from the bridge, port, starboard, whatever, that is being taken by electronic controls, okay, and it's being transmitted to the torque motor. Now this torque motor, it has got some hydraulic parts which you see in the when you see about this, but it will transmit the signal, all right, to the hydraulic servo controller over there. Which means there is again a hydraulic servo controller. The servo controller has got some a small what do you call input of hydraulic oil, constant pressure, and it will depend on the output of the torque motor. It will give its you know uh, output to this Jenny pump. Jenny pump is a type of a what do you call rotary piston pump, which takes care of the output for the steering gear controls. And if there is an how much ever is required by the Jenny pump as to operate the pump, that much amount of the proportional signal will be given in a hydraulic signal to the Jenny pump to operate, and the Jenny pump will start moving the actuator. That means the rams or the rotary vane, whatever it be, and that will go give to move the rudder. All right. Here you have a servo controller. After the servo controller, there is a return line back to the torque motor outlet. If there is more, there are obviously control mechanisms which have not been shown here. But basically, that is the idea. If there is an excess as the rudder control is received, then the whatever was the final transmission, this will go back to it. If the rudder is not about to not going to move back further, means if you had 15, 20 degrees and it has been reached, then it will stop this flow and it will go back to the entire top. Actually, doesn't go back to the system. It goes back into the reservoir, the hydraulic reservoirs for the pump. Okay. Then there is a feedback transmitter for the rudder feedback. Actually, as the rudder has achieved its maximum angle, it will also give back to the bridge. So means one feedback is there from the actuation of the torque motor, means the torque motor has started to move, and one feedback is there from to the steering side. Then, if the torque motor fails, you have an emergency control over here that is also controlling the same system. Okay, we will see this in depth when we just see now next the torque motor what exactly is it. This is just the flow of the entire system how it works. So this all is an electronic control right up to the torque motor. After this is a hydraulic control, means servo controller, Jenny pump, and everything. And again, this is the feedback is all electrical controls, electrical feedbacks. Means as the rudder is achieving its desired output. Now you will find only these types of controls in your uh, manuals. Most of your RAM type steering gear or your rotary wheel steering gear manuals, you have got these types of torque motors. Okay, so that's why it's better to talk about it. So see, we will see this hydraulic circuit later on also of the RAM type, but I just want to show you that see this is a hydraulic circuit, and you see here this is the entire torque motor which is actually controlling the stroke of the main pump. Okay, you see, and this is the servo controller which we saw below. जो उसका जो the servo controller and a small servo pump for the control of this of the torque motor. Means the servo pump is giving a constant pressure here, and a torque motor is controlling this servo controller. That means again it's a spool type of wall, but a larger wall, and that is out controlling the output from this servo piston, which was the actuator which we saw there, to not actuator, sorry, the servo piston, and to move the entire pump, the stroke of the pump. Okay, so the stroke of the pump is adjusted by this torque motor. So this is what is the this is. So you see, one is for the port side and one is for the starboard side. Sorry, number one and number two steering gear controls, both of them are there. This is a 4 RAM system. We will see this system in depth later on. Okay. So this part, because when we discuss about the remainder part, we should know what is this initial part, which is the torque motor. Okay. So this torque motor is there for even for RAM type steering gears, even for your rotary wheel type of steering gears, because it is a very seamless control, as you say. There is no uh, limitations to the controls. You can control this faster. You can have it moving also faster. Okay, just give me a second. And not the problems of the as you have the uh, mechanical controls which is there. Okay, just give me a second. So what you see here, okay, uh,
Are you muted, sir?
इधर चले गए सर।
करेंगे ज्वाइन, डिस्कनेक्ट हो गया।
अच्छा, ये तुम कहाँ से, कौन से एमएमडी से दे रहे हो?
नोएडा।
अच्छा अच्छा, ये कौन से नोट्स से पढ़ रहे हो अभी?
मतलब
पं- मतलब तैयारी मोटे एमएमडी का किससे कर रहे हो ये? पंकज सिंह से क्या?
नहीं, ऐसा तो कुछ नहीं है, नॉर्मल किताब किताब ही पढ़ रहा हूँ, टॉपिक्स पढ़ रहा हूँ बस।
अच्छा अच्छा।
Sorry about that, guys. I got disconnected. Kevin, can you please make me the host? In the participants tab, right click.
Yeah, sure. Just give me a second, sir.
So we were talking about the.
Done.
Yeah, thank you. We were talking about the motor when I got disconnected. So you see, as I was saying, the stock motor is a seamless control, electronic control, not relying on the mechanical leakages and the biggest problem over there was the tele motor. If the tele motor was receiving any problems, then straight away the control of your steering gear used to be affected directly by that. So just give me a second. The playlist. So here we have the top motor. Let it open, just hold on. All right. So just give me a second. So what we have here, okay, is the entire system. This is a steering stand. This is a control box, the same thing what we saw in that, this thing. And now this entire thing is the control unit and including the torque motor. So torque motor is basically a motor which is connected to this entire shaft. And what it does basically, again, usually this is somewhat similar to your floating lever of your hunting gear. Okay, but now this thing is slightly different. How it operates is, see, you've got some ports. You've got a capital A, capital B side of your piston, all right, hydraulic piston, and you've got this entire servo motor which is having three ports A, B, and C, as you see here. And here on the end of this, you have a differential transformer, LVDT, low voltage differential transformer, which is acting like a feedback. Okay. So and this is the top motor, the same thing is shown at the top. Now the top motor is being activated from the bridge. So it will give the signal over here, and it will give the signal to the top motor. As that occurs, it will start turning the top motor, and then the top motor is connected to this shaft, and it will start moving this entire spool either inwards or outwards, depending on the operation of the top motor. Right. So see, and when that occurs, there is a constant main from the hydraulic pump. There is a secondary hydraulic flow which is coming here to this wall, which is stopped. Okay. Now, what we'll see what happens. So, the signal of the order rudder angle is compared with the feedback signal of the rudder actuator angle at the steering can, and its deviation signal is transformed to the pump control signal in the control box. In the pressure. By this signal, the top motor is driven and the hydraulic pump is tilted through the hydraulic regulator. Okay. Like this entire thing is called as the hydraulic regulator. This dotted thing is called as the hydraulic regulator. Okay, which was in that line diagram was that smaller thing below the top motor. The entire thing is it is actually quite small. I'll show you exactly how it looks also. When you go on the ship, you can actually see it. Now, the oil is constantly discharged from the hydraulic pump and is applied to the hydraulic cylinder, and the tiller will be rotated through the main ram and pin. That means they will be rotated through the ram and pin. Now the top motor is stopped when the pump tilting angle reaches the corresponding to the pump control signal. Basically, there is a control signal coming from the pump, the feedback, and the top motor will be stopped when the tilting of the pump control signal is effectively same, because the electrical signal from the pump angle is feedback to the control signal by differential transfer. That means whatever signal is being given will keep on tilting the stop motor until the differential transformer says that control angle is received. That means either 35 degrees port or 35 degrees starboard, whatever is being received, that is being received by the differential transformer. Until that time, the entire thing will be keep on operating. Means until that time, that entire signal is being not been achieved. So that means this control will be before the actual rudder is achieved. Means whatever maximum angle you want, either port or starboard, to the maximum angle which is possible, it will be there. And until this maximum angle is achieved, this top motor will keep on operating. That means it will keep on moving to the. It will keep on moving. Just hold on. It will keep on moving this differential transformer. So basically, this is the shaft, and as this see, this is how the top motor this thing looks like from top. So this is how the shaft is there. This is what you see here is a neutral position. That means top motor, this control shaft regulator is in a neutral position. So if it operates, it will push this entire shaft either inwards or it will push it outwards. Okay, we've got different positions. We'll see below. Okay, and as it does, it will operate and close some what you call spool valves will be opened and closed, and there will be some hydraulic flow from this pump control uh, from this auxiliary pump to the with either side of this what do you call hydraulic piston. So what you have, it is a proportional to the rudder angle and nearest to the rudder angle. See, basically idea क्या बोल रहा है कि until your angle which is desired by the from the bridge is received, the top motor will keep on pushing this entire hydraulic regulator. Okay, so let's talk about the hydraulic regulator now. The pilot spool 202 of the hydraulic regulator is moved by a top motor 101. So we see this pilot spool, this entire thing is moved by this top motor regulator, this piston, which is moving up and down. Okay? Up and down, it's inward and outward. Okay? Now the servo piston is connected to the cylinder casing of the hydraulic pump and is also moved with the help of pressure oil generated from the servo pump, and the oil is discharged from the hydraulic pump. Operation regulator is operated in figure 12. So you see here, that means this oil tank will from the oil tank, the second filter is there, and it is either discharging to this side from directly from this from the hydraulic piston side number A, and oil is going to this what you call spool piston position number A. Now, if the movement of this entire thing goes inwards or outwards, the oil will move either to point position number B also. Okay, or either it will only come to position number A. Now, in this position, when it is locked, both the A side is locked and the B side is both locked. So this pump control lever will be in a neutral position. It will not be moving. Okay. Now, the rotor shaft of the top motor is connected to the pilot spool 202, and rotational movement is converted to the stroke of the piston for the pool. The servo piston 403 is connected to the tilting pin of the pump, and movement of the piston is transmitted to the pump. This is the tilting pin, entire thing, tilting pin of the pump, and it is converting to the stroke of the transfer of the pump. Okay. Now, while the servo piston is connected to the feedback sleeve through the feedback lever, the stroke of the piston is feedback to the feed service also. So what he's saying, that whatever the stroke of it is feedback from the LVDT back to here, as well as what is the movement which is there of the rudder is also giving back to the rudder, to the feedback unit in the bridge also. Okay. So now we talk about this neutral stroke position. Now accordingly, the servo piston 403, this one, all right, this entire servo piston moves rightwards and stops at the position where the feedback sleeve 203 closes the oil passage to B to drain A. So it means basically the passage B है बंद हो जाता है in the neutral position. That means this entire spool is closed. That means this feedback, this larger side of the cylinder and the smaller side of the cylinder both are locked. Okay. Now the servo piston 403 tilts the pump in the same direction by the same angle in accordance with the movement of the pilot spool. So this is the pilot spool, the small one. All right. Now there is another angle which is this is the movement angle from the neutral position. Okay. We'll see each position. Neutral position either to the torque under or whichever operation, either port or starboard, and then again coming back to the neutral position back, how it does that. Okay. So here, all right, what we see here. Hold on. Sorry about that. All right. So the servo piston tilts the pump in the same direction by the same angle in accordance with the movement of the pilot spool. When the pilot spool 20 is controlled, led to pulling out direction, means leftward in the figure. The pressure in the oil is led to both chamber A and B. You see, this entire system works like this: that there is oil which is coming up here from the main reservoir. This is the lead of line. It is going back to the reservoir. This is the auxiliary pump which is operating this entire servo piston. Okay, and as this pump operates, it will either give the oil to either this side or this side. Okay, more or less. Okay. Now what happens is that this top motor is connected to a piston. I'll just show you how it looks like. So see, this thing. You see this thing? This is a vertical, what do you call, uh, stopper sleeve or whatever they call it. Okay. Now this is connected to a motor, and this actually moves left or right. It moves onto the 30-degree port or 30-degree starboard from the central position by the operation of this motor. The motor is basically controlling the operation of this stopper sleeve. And what this stopper sleeve is connected to bottom, all right, at the bottom side, it is connected to this, what you call, what you call, small piece, which is a stopper sleeve piston, and it pushes or pulls this entire spool piston. Okay, basic idea वही है. So मतलब in a neutral position, this oil is drained back from this side. So both of the sides are locked. That is not moving this entire servo piston. Okay, because even if the oil is coming, the oil is coming on this side, and the other side is locked. This side is locked. Okay, what you see C is the which is connected to the drain side. Okay. So what happens is that there will be no motion of this servo piston, okay, and it will not move ahead or behind, and the hydraulic pump which will be staying at neutral stroke. Okay, whatever the pump is there, either radial piston or yeah, other type. Okay, it is going to be staying at the neutral piston, no neutral position. Okay, it will not move. Now, what happens is, suppose you give the signal from the torque motor, it moves it inwards or outwards. Suppose it moves it, I won't read through the entire thing. Now it pushes it onto this side. Now, what happens as soon as I push to this side, the entire B side is connected to the drain through the port B. Now, the port B is spool piston is slide over, and now it is connected to the drain side of it. And now if your stroke is there with the constant pressure pump which is operating, it is going to generate a pump pressure, and it will push this hydraulic piston in this side, and the oil will go back to the drain of the reservoir. And now it will move the entire stroke of the pump to one side of the entire thing. So basically it is going to port side or starboard side. Similarly, if you want to go the other side direction, now the spool piston valve which is there will be moved by the by the torque motor movement, okay, and it will move it in the other direction. It moves in another direction, and this entire there is a spring in this side in the regulator which will push the spool piston towards the other direction. As it moves to the other direction, this is pinned to this whatever hydraulic piston also. Okay, so hydraulic piston is also pulled in the other direction. So hydraulic piston being pulled in the other direction. Now what happens is the oil flow which is happening, which will go to this side, is a smaller side. It goes to the chamber A, but now this side is closed. So it goes from here and it goes to this back side, and it pushes the hydraulic piston in the other direction. Okay, so it will now slowly move back, and now the stroke is reversed. Basically, this is the entire operation. Okay, basically the torque motor moves it into a particular angle, 30-35 degrees on each side. What is the maximum angle? As it does, okay, it will push this linkage. All right, and at that time, this piston will be also free to move. It will not move. Movement will be only there by the hydraulic oil. Okay, hydraulic oil will push this entire piston. Mean it will be free to move along with the linkage. Okay, that is the idea. And this is how the operation is there. And if you want to get back to a neutral stroke, you have to again move this torque motor, what you call stopper sleeve, back to the neutral position, and that will close the spool piston valves, and that will again get back to this neutral position. And immediately now, because as that occurs, there is lesser pressure, higher pressure on this side, it will again come back to the neutral position very fast. And as soon as that occurs, the pump will go back to neutral stroke. Okay. It is I hope you're able to understand how this operation works, because they ask about this. Okay. And this is where your entire this thing is there. ये torque motor देखो ऊपर यहाँ पे एक motor है, the black one. This is a torque mode, and you can actually see the angle also as it moves. This shaft is connected to the same thing on top. This cover is there, and this is a DC torque motor. I forgot to tell you, it's a DC what do you call brushless motor. Okay, it operates like that, and this will move either whatever directions you can move it. It will come directly over there. So suppose this entire thing, stops working also. Okay, so that means your torque motor stops working. At that time, you can disconnect the electronic controls and you can actually control this by hand. So this is also serving the hand control for the emergency operation. You can control this by hand. You can move this entire thing on top, this knob on top, and it is connected to this what you call this sleeve. Okay, through this shaft down there. And now earlier, what was happening by the DC motor, now that will happen by your hand control. The hand will move it, and that will effectively control this entire thing. Okay, so they control the spool piston operation, and as the spool piston is operated, simultaneously the hydraulic flow will also take place. Okay, either in the port or starboard direction. So this is the emergency control which is replacing that spool piston operation for the telemotor operation. In the telemotor which we saw, emergency control was there. So this is part of that. So if in case the linkages from the control system, this electronic control which is coming from the bridge, that fails, all right, then you can operate this locally by the knob system. So there is two controls. One is the emergency control from the for the top motor, and then you have got the control system for the electronic controls for the solenoid valves controlling the ram movement. Okay, this is again about the bridge control. When we talk about the changeover of the system for the follow up, non follow up, we again talk about that. But is this top motor thing कुछ समझ आ रहा है आप लोग को इसके बारे में?
Yes, yes.
Because see, this thing might be something new because in the textbooks you do not have this entire thing. You might have just mention even in your manuals that top motor is there, but ये कैसे काम करता है is important. Because see, there is a DC motor, and DC motor controls the spool valve, and as the spool moves, proportionately this piston moves. Okay, both of them operate together. That means as the spool moves, similarly simultaneously this piston will move. Not that के one effect follows the other. जैसे आपका hunting gear में क्या था, पहले आपको एक पूरा movement होना है, उसके बाद फिर either your pump will go to stroke or pump will stop to stroke. यहाँ पे क्या है, जैसा आपने control दिया है 5 degree, 5 degree, 4 degree, 6 degrees, 10 degrees, जैसा देते हो, you move that immediately, that system moves. So that's why it's called a seamless control. So in that you had the linkages had to move first, and this thing. This is also a control linkage, okay? But this control linkage ensures that there is no both of them operate together. It's not that spool valve operates and then your piston operates. Both of them have to operate together, and then only your system will be. Okay? Basic idea वही है that there is spool control valves and there is a main hydraulic piston. Okay? Hydraulic piston either moves from left or right as per the control of the spool control valves, which is effectively controlled by this stopper lever, which is moving that entire control system. ठीक है, ये जो नीचे का जो है वो दिखा दिया, ये ऊपर का भी सिस्टम वैसा ही, ठीक है. So this can be serving as the emergency control for the torque motor. ठीक है. So they ask this to explain torque motor and explain its emergency controls. The emergency control is basically this only. You just have to disconnect this electronic socket. As soon as that is disconnected, the motor will be de-energized. So initially the motor will be energized and it will hold this entire stop lever at one position. Okay. But suppose this thing is there, so you see this receptacle which is there, this needs to be plugged out, and then your motor will be de-energized, and then you can operate this knob by manually, and this will lock. There's a small amount of ratcheting in this, so until you actually press this knob further, it will not move in. There are got 3 or 4 steps, like you see 1, 2, 3, 4. 1 or 4, 2 or 4, 3 or 4, 4 or 4 on either port and starboard side. Okay. Similar operation for the port, similar operation for starboard. But it will only operate in case you have after de-energizing the entire motor. Okay. The DC coil motor, it will keep on energized. And see, there is a clamp and everything, and also this basically वो de-energized condition में वो उसको छोड़ देता है. Energized condition में it locks the entire shaft in one position. Okay. Once that motor is the current is stopped, it will stop in that position only. Okay, तो वो करना पड़ता है आपको इसके अंदर. Okay, this is the in case of your telemotor, they replace it by a torque motor. ठीक है. And हाँ जी बोलिए.
Can you please share this file, sir? ये talk motor वाला.
ठीक है, I will share it with you. I will put it on the group because you just have to read it. Because see, actually मैंने just निकाला था. I think I removed it from some manual. ठीक है, and ठीक है, I will share it with you guys.
Thanks, sir. Thanks.
One second.
Because ये material sir और कहीं पे भी मिलेगा नहीं टेक्स्ट बुक वगैरह में कहीं पे भी.
I know, it's not there. ये भी मेरे को बहुत मुश्किल से मिला था. Because what happened is previous batch में ना, there was one chap who was interested in this, so I removed it. But after that only they started asking about torque motor control and effectively how it works. I don't want to read through the entire thing, but basic idea तो आप लोग समझ गए हो how it works. ठीक है. There is a drain wall on top of this. ये जो ऊपर वाले एक drain wall है, ये जो है, ये drain wall इसमें एक है दिया हुआ है. That is effectively basically again small coil है इसके अंदर. ठीक है. As long as the motor is energized, this will lock the system in place and this drain wall will be closed. So basically it is to de-energize both sides of the spool piston. Basically once the system is operated, is in a neutral position, okay, at that for a few seconds this drain wall will open and will de-energize whatever is the higher side, either the A or B side, whichever is the higher side, it will de-energize it from this side so that this spool piston does not what you call get always be pressurized in condition. ठीक है, वैसा एक उसके अंदर ये दिया होता है mechanism. Okay, अच्छा इसका एक और चीज है, this bridge thing I'll talk about it later on. Local control, hand control. See, we'll see about the advantage of this fully electric system over mechanical hydraulic. अच्छा, let's see the advantage of this later on because when we do the non-follow-up or the follow-up ना, उसके अंदर भी इसका आएगा कि the control mechanism क्या है and everything. ये मैं आपको share करूँगा तभी because no point in discussing about it now because unless you know the follow up and non follow up system. उसके अंदर भी कुछ there are some systems in that. ठीक है. Now where was I? Yeah, we will talk about the power actuating units. ठीक है. The power units, which is basically your when I say power units, I mean your ramps and your vane type of steering disc. Exactly क्या है, and your ward gear nut system. Those are the power units. So sometimes surveyors they ask explain the rudder power units. So rudder power units, when they talk about, they're talking about whatever is the actuation systems. Okay, he wants to know that whether you know that power unit because see, generally speaking, power units you think about maybe the pump or the motor or whatever thing that is. But in the rudder, when you talk about power units, you're talking about the basically hydraulic cylinder or electronic motor, whichever. Okay, so rudder can be moved by either using hydraulic cylinder or electric motor type of power units. So there can be a 2 or 4 ram hydraulic ram system or a 2 ram actuator system. This is there again on smaller vessels or vessels where there is a requirement for space. Like they don't have adequate headroom or they don't have adequate room for the entire rams to be arranged in a linear manner. They have it in a compact manner in that manner. So ये 2 ram उसमें होता है. Then rotary vane is a totally different type of system. We'll see that. And wall layer node is again a different type of system. Okay. Now this power unit can be controlled by purely hydraulic means, electro-hydraulic or purely electrical. Okay, we'll be discussing that later. Purely electrical is this wall layer node. बाकी सब आपका electro-hydraulic या hydraulic means से होता है. Now see, these are some systems. Okay, what you see here is a 2 ram system fitted with something called as a Rapson slide. Okay. Here in figure number B, you have got a single oscillating double acting cylinder, okay, which can also work as a steering gear, okay, for again not for larger vessels, because see double acting cylinder has, so it can work as in for both sides. The piston can be actuated from both sides. This one requires that single cylinder is there, so it can be a single acting system or a double acting, depends on the design. But this one has to be a double acting if it has to operate for both sides. Okay, for port and starting. So again, a single actuating cylinder is there. Okay. Then C, what you see here down is a twin rudder installation. Basically, 2 rudders are there. Okay, with 4 oscillating cylinders. Okay, 1, 2, 3, 4. 4 of them oscillating, and you've got a twin rudder system. Again, this is for smaller ships. Okay, it's not there for larger vessels, because you don't require two rudders. This is only for your offshore vessels, tugs, and so forth. Okay. Then fourth D, what you see is a 4-cylinder link gear. So you see there is cylinder number 1, cylinder number 2, cylinder number 3, and cylinder number 4. So 4 cylinders are connected, and there is a linkage over here where you have got the entire rudder stock connected over here. The rudder stock is not here, the rudder stock is here. Why this system is made? Where effectively this vessel might have a problem with the size. So basically you wanted the entire system to be more compact. So जो generally आपके 4 ram system में या 4 cylinders and 2 ram system में जो center में जो tiller होता है, यहाँ पे ये लोग ने ये tiller का arrangement side पे दे दिया, ठीक है. So this is also one arrangement where you can have 4 rams. Okay, actually not 4 rams. There are 4 cylinders and 2 rams to be perfectly true. Okay. Then this is a rotary vane system. Okay, actuator system, and this is a different type of rotary vane called as a N-Ford. T is silent over here. N-Ford, or it's like a what do you call Polish. This was the rotary vane system. This is again no longer there. We have only the standard rotary vane system, which is much more common. So we will be talking about this system and your RAM system, 2 rams or 4 rams, and then we'll be talking about your actuator system like this, either having the 4 rams or 2 rams. Just give me a second. All right. So RAM type. Okay, this can be made up of a 2 ram system or 4 ram system. Considering 2 ram system, the operating principle is as follows. Okay, basically talking about this 2 ram system. All right. The telemotor receiver cylinder moving to left or right. Again, it says moving or left to right. This movement moves the lever, which has a fulcrum, and again about the telemotor. Considering Hay shop pump, which is running the radial piston pump, running at all the time. When the floating ring is moved to start the pump, hydraulic fluid is sent to the right hand cylinder. Again, it's talking about the pump. We have gone through this all before. The tiller arm, which it is at right angles to the center line of the arms, as you see here. Tiller arm is basically at right angles when they're in the center position. Okay, it is fitted to a crosset. Now see, there are certain mechanisms where you can have the connection of the rams to the tiller. One of them is crosset systems, which have got something called the Rapson slide mechanism, and that also has got certain different types of systems. You've got 2 systems. इसमें एक fork tiller as you see here, and one is a round pin tiller. We'll see both of them in a action. Okay, tiller arm is connected to the bottom lever, the buffer spring and ring called a hunting gear. We've seen that also. This entire thing is talking about the same thing. Like you got a port ram, starboard ram, 2 ram system. Hunting gear is there, and ये सब है. ये तो हमने देख लिया. ठीक है. Now see, a tiller with 2 rams is keyed to the rudder stock. Now this ram to the rudder stock keying can also be in 2 or 3 different types. When we talk about the how this system is arranged, the actual system of the system, when we see the line diagram to the system, we will see also how this tiller is connected to the rudder stock. Okay. So we basically is talking about this rudder stock arrangement and this entire tiller arm. So either it can be keyed, or as I said, it can be also on a taper with a hydraulic connections, and one is a taper with hydraulic connection along with a key. Okay, it depends on 2-3. We will see this when we see the entire thing. उसके अंदर भी एक calculation होता है जो आपको दिखाना बच गया कि there is a force for pulling off the rudder from the tiller, and there's something else. We discussed that when we discussed the actual manual के जो systems है तभी देखेंगे. Now the tiller is then connected at each end through civil blocks to the pistons of the 2 hydraulic rams. The cylinders of these hydraulic pistons are arranged so that one receives the oil and other loses the oil, so that causing the position of the piston, and therefore the tiller arm to move. Basically, the oil comes in one side and the oil goes out from one side. If you have a single acting cylinder, the 2 ram system version can be possible using only just one tiller arm. Okay, that means just one of this system like this. Just one tiller arm, and you can have 2 ram system. All right, but the cylinders may be single acting or double acting. If double acting system could still fulfill the single failure criteria, because it requires that the tiller and the what you call arms need not be duplicate for a single failure criteria, which is talked about before. Now, this is again a 4 RAM system. Okay, what you have here is the central trigger, and you have got here the connection to the RAMs. So you got one RAM here, one RAM here, and you got 4 cylinders. Okay? We will see the exact line diagrams, not concentrate on these diagrammatic, just arrangement which you see here. But again, the idea is that 2 motors, okay, both of them taking from a tank, and they are operating either together or independently, depending on the requirement of the motor. Whether they are both are at 100%, both can operate the entire system together, or if they require 50%, then both of them requirement is there together to supply the entire 100%. Means either one could be operating at 100% load if they are designed that way, or they could be at 50% load if they are operating together. It depends on that system, which is we read the rules, right? The rules में दिया हुआ था कि either both the system need to be working together or independently need to be operated at a main and auxiliary steering gear. So again, one more photograph of it. So here, before going any further, we will discuss these connections. कि रडर स्टॉक से जो जो आपका जो रैम का जो कनेक्शन है वो कैसा होता है, ठीक है. So okay, let's just go over the important parts. Include crosshead slippers. Basically, this is a crosshead, and there is a slipper over here, which is basically connected to the entire, moving along with the crosshead. Okay. These are bolted to the side of the ram and slide onto the surface of the guide beams. They transmit all the radial thrust to the guide beams. Basically, they just transmit the radial thrust. These are connected over here, and they allow the slipping action of the entire ram. Okay, the ram is moving along with it. All right, and the same thing. These are connected to the guide beam. This guide beam is basically a vertical beam on both sides of the arrangement, and this is non-movable. So this crosshead slippers don't move. The crosshead just slides along with the entire ram. The guide beams, these brace the pairs of cylinders and stop them from being pushed apart. They also transmit the radial thrust to the ship's hull. Basically, all the radial thrust has been transmitted to the ship's hull because they are rigid parts. Okay. The cylinder feet, these are substantial and bolted to the equipment bed plate. What you have here, this one. Okay. These are connected to the cylinders to the bed plate of the steering platform. Okay. Crosshead trunnion bearings, these allow the linear motion of the rams to be transferred to the rotary motion of the rudder stop. So this is a crosshead over here in the center, top view. Now we'll see how what was the design for this basically. So what this arrangement is called as a Rapson slide. Now this can be arranged with a solid what you call tiller arm going through a hollow part of the ram. Okay, and you have arrangement that way, or you can have the tiller arm in a forked way. Means there is a fork on the ends, and that fork is having a solid ram which is not having any hole. Okay, but a large hole as such. But there is a ram pin through that to arrangement. Just give me a second. I'll show you what I mean.
सर
जी बोलिए बोलिए बोलिए.
सर वो जो डाउट था ना
कर देंगे
वो इससे ही क्लियर हो रहा है सर.
हाँ,
ये
because
जो दो अलग अलग जो डिजाइन है ना इसकी वजह से क्लियर हो रहा है.
मैं दिखा दूंगा. टॉक अबाउट इट. जस्ट गिव मी अ सेकंड. So see here, ये आपका अरेंजमेंट है. Rapson slide mechanism, rotary vane, and pinch actuator. We will talk about the Rapson slide mechanism first now. So you see, for crosshead arrangements, there are 2 mechanisms. One is on the left, one is on the right. So on the left is having the central crosshead over here, and you have the ram which has got a big opening in the center. Okay, and you have got there is a trunnion part of it which is connected to the crossheads, and the entire thing moves left and right along with that. Okay, so the arrangement is that the rams have got a big hollow part in the center. It is the rams are casted in such a way that there is a big hollow part in the center, and the big crosshead can be connected in the center. Okay, so इसमें और ये दूसरा वाला राइट साइड पे मैकेनिज्म है. यहाँ पे क्या है, रैम पूरा यूनिफॉर्म क्रॉस सेक्शन है. ओनली देयर इज अ area where a vertical pin is pinned to that. Okay, and you see the uniform cross section of the ram is there, and now you've got a pin through that, and there is a swivel block on the top, and this is a fork design. So one is a round tiller arm design, one is a forked tiller design. Now both of them are the Rapson slide only. Okay, and later on when we talk about the mechanical advantage, you will understand why this mechanism is the best. Okay, in compared with the Rapson slide, rotary vane, and pinned actuator. So the two designs here of the Rapson slide. One is having this crosshead mechanism where a large crosshead is there, and you have the entire thing which is having a trunnion on top, and it is actuating in that. And then you have got one mechanism where one uniform pin is there, ram is there, and a vertical pin is going through that. ठीक है, तो ये इसका टॉप व्यू है फोक टिलर का, और ये है टॉप व्यू राउंड टिलर आर्म का. Now when you consider both of them together, you will understand why there is a difference in the clearances. What clearances I'm talking about? The wear down and the jumping clearance. Okay, we will see them both now. Okay. So first is this crosshead arrangement. This arrangement, alright. So the large crosshead is there, and then you've got a bearing surface over here in the trunnion on top. Okay, and this is the bigger crosshead with a solid tiller. That means the tiller is one complete part. Okay, and that is passing through this crosshead. There is again a bearing area over here and a bearing area vertical over here. Okay. So there are several designs of the crosshead, and one described here. This is a solid tiller arm, and other with a forked hydraulic arm. ठीक है, तो ये solid tiller arm पहले देखेंगे, फिर हम forked hydraulic arm का देखेंगे. Now the tiller arm is solid and passes through the center of the crosshead pin. The pin is fitted with a sleeve bearing which will allow the tiller arm to slide in and out. The two hydraulic arms are forked at the end and bolted together. That means in case if there is a hydraulic arms which are forked, ठीक है, तो उसमें bolting रहेगा together. यहाँ पे बीच में ये आपका जो hydraulic rams है, उसको यहाँ पे ये उन्होंने बोल्ट कर दिया. Because see, either one mechanism is you have the entire ram which is one part, and you are having a opening in the middle as I showed there. Other way is you have the two what you call hydraulic rams which are connected by bolting mechanism. Means you have got one hydraulic ram with a C face on one side, and one hydraulic ram with again with a C clamp side type. Both of them are clamped together. Okay? That was now the crosshead pin previously mentioned is fitted vertically in the fork of the ram end. That means this entire thing is one thing. Okay, ये पूरा ये जो crosshead pin is entire one mechanism is there, and it is quite a substantial thing. Means it has to be much bigger than the tiller arm, the diameter of it, because it is transmitting all the thrust in the vertical horizontal fashion. Means to the rams. The rams are arranged like this, right? The rams are in the port and starboard direction, and this is in the central, in the forward and aft direction. Okay. So as the rams, the crosshead pin and the bearing surface which it passes through the ram ends allows it to rotate. As the rams move, they push the crosshead pin in a horizontal direction, as I said, and the motion of the pin will cause the tiller arm to move up, but it is constrained to move in a rotational direction. So basically, it will not be allowing to move up. So इसलिए it will allow it to move in the horizontal direction, because यहाँ पे ये पूरा इसका crosshead का जो weight है is quite a substantial thing. ठीक है? So it will slide in or out of the pin as it rotates to the movement of the pin. That means it will go either at one part, it will be as it goes in the port and starboard direction. This entire thing will push the crosshead to the starboard or port direction, and this will slide in and out of the crosshead bearing. The crosshead का जो horizontal bearing है, इसके through in and out slide करेगा. Means as it moves from port or starboard direction, this will move in and out. The tiller will move in and out. Basically, when it is at the 35-degree starboard direction, this end of the tiller might be right at the end of this crosshead, and it is at the 35 port direction. Again, it will be at the neutral position. में ये center में सबसे ज़्यादा रहेगा. जो tiller का जो arm का protuberance from this what you call crosshead arrangement. ठीक है? Now, crosshead will move out of the pin, and the crosshead arrangement must include allowances for rudder carrier bearing wear down and the rudder jumping gear. These are both shown in the sketch. So you see, this arrangement has got a large crosshead which is one complete piece. Okay, So this tiller arm, the weight of this crosshead is taken on the tiller arm, and the weight of the tiller arm is taken on the rudder carrier bearing. So if the rudder carrier bearing wears down, now in this case, there you have got forked rams and you have a tiller arm which is solid. Okay. So you have the tiller arm which is solid and the rams are forked. Okay, FORKED. Okay. So now that's why what is happening over here, as the rudder carrier bearing wears down, you have to give adequate clearance on the bottom side for the wear down. Otherwise, these crosshead will go and touch the rams. Okay. Now the crosshead will go and touch the ram and it will wear down the ram. Okay. So now what is this part? This part is the ram and this part is the crosshead. Okay. And now similarly, if the rudder jumps up, the transition from the rudder carrier bearing is transited upwards to the rudder and to the tiller effectively. The tiller will now go and jump up and it will touch the rams, and this will lead to bending of the ram. So to prevent that, there is a jumping bar at the bottom of the rudder, and then there is this clearance which is about 8 mm at the top of this thing. Okay. So this is the standard what you call arrangement which you see in all your textbooks. Okay. Your
right, sir.
George, your marine auxiliary machinery, your maintenance textbooks. This is a standard one. Now this arrangement is a very old one. Now what they have replaced this is what? With a tiller arm which is forked and the rams which are uniform. Okay. एक में क्या था, इसमें क्या है? Rams are the tiller arm is uniform and the rams are forked. Now what they've replaced it with, the ram being uniform and the tiller arm being forked. So that arrangement we'll see next. Okay. One second. Okay. So see, this mechanism is called as Rapson slide. The purpose of the Rapson slide is transmit the linear movement of the hydraulic ram to the rudder stalk by imparting a turning movement to the stalk. The mechanical advantage of the Rapson slide will increase with the angle which is the tiller is turning. Basically, we will see when we study about the mechanical advantage what exactly happens. This helps keep the effort of the rudder stalk constant as the force required to turn the rudder increases with angle going astern. Okay. Anyway, that is a different thing, but we'll see this Rapson slide mechanism later on. Sorry, the mechanical advantage later on. What is exactly is it? So just give me a second.
Sir, you're muted, sir.
Okay, thank you. So here you see the solid rudder stalk in the center, which is keyed to the tiller arm. Okay, and the tiller arm is connected to this solid tiller is one piece. This entire piece, okay, one piece, and you have got a solid tiller arm. The central piece is solid, and now you see these are the forked ends, basically the forked ends of the ram. Okay. Now this arrangement is an older arrangement. It is no longer used because the Rapson slide is still used, but they have changed this arrangement because why? What is happening here? You have got a ram which is not uniform. You've got one ram, then you've got a flange which is connected to the C, this clamping piece, like this clamp is there on one side and another side, which is joined together center. Okay. So arrangement is that it basically what happens is again moving there are a lot of problem with this arrangement. That means it has got these bolts and everything. So the RAM not being one piece, and ultimately, if these bolts fail, then this the movement can be also getting be problematic. Okay. So then this mechanism was changed. What they changed this mechanism was, which they did that they realized that the rams need to be much more solid than your tiller arm. The tiller arm can be of a different design, and your rams need to be solid. So they changed this they made the ram, the tiller arm being forked and the ram being solid. Okay, that new arrangement is somewhat like this. Okay, this is the newer arrangement. That means your rams are ram is one piece. Okay, and there might be a hole to that to allow the central ram pin, and you've got that thing over there. and this is the entire what you call tiller arm, which is now forked design. Okay. So in case of the fork tiller design, the thrust from the rams is transferred to the tiller through swivel blocks. So these are swivel blocks, these square things. Okay. Let me show you a better the diagram of this. Just give me a second. You see here, this entire thing, this is what they call it as a ram pin bush, is a swivel block. Okay. So here, this is the entire fork design, and this is the swivel block. The swivel block goes on this ram pin. Okay, you've got two of these swivel blocks. One ram pin bush, what they're calling as ram pin bush here is basically a swivel block, and this goes on top and the bottom. And what you have the ram pin which is going through the entire ram. So you understand the ram is now much more resilient because now the ram pin is a very small diameter in compared with the entire diameter of the ram. So it becomes much more resilient. So the idea is the entire diameter of the ram can be reduced. Earlier you had to have much more bigger rams because you had the break in the you didn't have uniform cross section. Here it is more or less uniform cross section, and then what is there because they've made the hole in the entire ram. What they've done, they've put an additional sleeve, which you see here. Okay, एक additional sleeve डाल दिया इसके ऊपर to give the more rigidity. Okay, so sleeve is put and then is there. So now what this relates to, here you have got clearance upper and one lower. But now the clearances are ulta. So what is the lower one is the jumping clearance and the upper one is the wear down clearance. Because earlier what you had is the ram was uniform, the tiller was uniform and the ram ends were forked. Here the ram is uniform and the tiller ends are forked. It is vice versa. So when they have changed that, obviously here, because see, if suppose I call this lower clearance as the wear down clearance and upper clearance as the jumping clearance, as it was the earlier design. Like earlier design stated that the upper clearance is the jumping clearance and the lower one is the wear down clearance. Okay. Suppose I say the same thing. Suppose I give values like this is 19 millimeters and this is 10 millimeters. So suppose the entire tiller goes down in this case. Okay. Then if it goes down, now the fork which is on top, which will come and touch the entire ram, which is only 10 millimeter clearance that I told about. So this was 10, this was 19. So although there is a 9 millimeter clearance below, the entire ram will go and touch the tiller will go and touch the ram. Because earlier the tiller was in the center, no? Tiller was in the center and the rams were up and down. Here they've interchanged the system. So that is the reason why when you take about this forked end system, what is on the bottom is the jumping clearance and what is on top is the wear down clearance. Okay, remember this. Okay, so basically this mechanism, when we have this mechanism, the upper one is the jumping clearance, bottom term is the wear down clearance. But when I talk about this mechanism, the upper one is a wear down clearance and the lower one is a jumping clearance. And this is what is on most of the vessels nowadays. Okay, nowadays we have this type of arrangement only. We do not have the solid ram clearance because you see that requires a lot of bolting of the unnecessary bolting of the ram, and the rams are also much more bigger in that case because there's a break in the system. No? You don't have that same uniform. The thrust is not taken in uniformity. So that is the basic idea why the clearances are different. Here, the upper clearance is a wear down, and the lower one is the jumping. And in this one, all right, in this one, the lower is a wear down, upper is the jumping. Because see, tiller arm is in the center, above and below are the rams. In that case, the tiller arm is not in the center, the ram is in the center, and the upper and below are the tillers. Okay, so that is the difference. So that's why you interchange that idea. So you have to have the change in the clearances also. Okay, is that understood by you guys? Because this is something when unless you understand that there for the Rapson slide there are two designs. Because generally you only talk about this design in the textbooks. They are not talking about the other designs. Okay. All right. Now just let's talk about we talk about this arrangement, but we didn't talk about the design of the Entire thing. Okay. Construction of the ram type of steering gears. In the ram type of steering gear, the rams, which will be a 2 ram or 4 ram, are made of cast steel and have a ground finish. They work in cylinders which are also made of cast steel. The cylinders are bolted to stools, and each pair of rams is longitudinally braced by an H-section beam. That means that guide beam which we talked about, which also provides a crosshead guide space. Okay. If there are 4 cylinder sets, then they are cross-based in heavy brackets. Basically, there's bracing given in the middle between. Pads are welded to the guide face to react as mechanical rudder stops in some arrangements. Okay, basically, but nowadays, what is the rudder stop? Also, I will just show you in another photograph. See, in nowadays, these act as a rudder stops. Uh, yeah, these ones. There is a guide, what you call rod, and the second this thing, this what you call type of arrangement. This is acting like a rudder stop. Yeah, you see this? This is a rudder stop, and this will go in at maximum angle, say 35 degrees. It will go and hit the what you call cross beam, which you have here across the two rudders, and it will not allow. This is serves as a rudder stop, as well as on the forward end you have the rudder indicator. Means both of the sides you have got this movement, and there is again a separate what you call guide beam, which is there, which is just sliding on that. There is no pinning in this; it is just sliding over that. Okay, in the newer folk design, this there. It is there in the folk design. So, acha, one more thing. When you are talking about this type of arrangements, okay, with the folk design arrangement, apart from these clearances, which are the vertical and vertical clearances, you have to also talk about the horizontal clearances. That means one clearance between the ramp pin bush and the what you call horizontal face of the tillers. Okay, that means of the folk tillers. That, and then you have to talk about the clearance between the ramp pin and the ramp pin bush. So what you see here, you've got this one clearance which is there between the ram pin and the ram pin bush, the central radial ram pin which is there, small one, is passing through the rams. उसके बीच में और bush के बीच में clearance थोड़ा होना चाहिए, ठीक है? Little amount of clearance. Then along with that, you have the clearance which is there at the top. Okay, this entire ram pin bush which is there is locked, and there is about a zero point 0.3 millimeters clearance over here, which is given in the top area for the locking pin, so that when your jumping action happens, there is about zero point 0.3 to 3.7 millimeters maximum, which is there. So entire thing will move up, but and there is a clearance on the bottom also for the jumping which I talked about. That is there. So this will be more than the jumping clearance. So if that jumping clearance is around 3 millimeters, this will be more than that. Okay, this movement. Then there is another clearance also, the vertical clearance between the rampant bush and the crosshead sliding face. Means that once when it is either port or starboard, you take the clearance between one side of the rampant and the horizontal face of the tiller, both upward and lower. So you have to take the upward and lower rampant bush and the horizontal face of the tiller at the upper side, and what you see here, this clearance between this thing entire rampant goes down. There is a clearance between the tiller arm and the rampant bush. So that is also to be checked, as well as the basic center clearance. And then I said that the locking plate clearance is also there. So these are also some clearances which are to be discussed, noted when you check the clearances in the system. Okay. So again, the ram ends are usually forked, as you saw the cross-side arrangement, and each pair of rams is bolted together, and these ends form the bearing half as shown below. They are bushed to form the top and bottom vertical bearings. This is again the forked end of the ram design, which is not the newer design. Newer design you already see, which take the clamp and pins and trunnion arm, civil block. Civil block is the pins are together as crosshead. He's talking about this thing, this crosshead. Sorry, this one. All right. Uh, the civil block is a horizontal gun metal bush. That means this earlier thing was a horizontal gun metal bush. Okay, through which passes the killer arm. Provision is made by the way of clearances as well as fuel block and the ram fork for wear down of the rudder and a killer arm to accommodate the vertical movement of the rudder. Okay. These two clearances are of utmost importance for the safe working of the cylinders and rams. That means the wear down and the jumping gears. any vertical movement of the rudder should not reflect the virtue of the forces of the crosshead. That means basically it should not, any vertical movement of the rudder upward or downward should not lead to the damage of the rams and this thing. Which is the crosshead should not go and touch the rams in this case. Okay. So to ensure it is important to make sure the wear down clearance is shown above should be at all times more than the pintle wear down arrangement. Basically, the wear down which is there over here of the rudder carrier bearing, which should be more than what the rudder carrier bearing is ever wear down. So that means even in the worst case where the rudder carrier bearing is worn down, this entire crosshead will not go and touch the rams. In the other case, that wear down clearance was on top, where we have got the forked ends of the killer. Okay. Then the jumping clearance as shown above would be all times more than the allowable vertical clearance for the rudder. Normally that is about 3 millimeters, so this is around 9 millimeters the vertical jumping clearance. So that is the clearances in the striking pad clearance and the pallister bearing. Pallister bearing is this vertical bearing, they're calling it the pallister bearing. Okay. Now the striking pads are put in between the rudder and the stern port. One should make sure that the stopper arrangement is effective for the all position of the rudder and hard port, hard stopper. He's talking about the maximum angle this can go, rudder stopper. Because again, there is some pad over there to prevent the maximum angle of the rudder to be absorbed. That means it will not allow the rudder to be going and hitting the this thing. Okay. Now, once we have understood that, any problem, any can you satisfy that doubt about that? What is the clearance and everything? उसके बारे में जो आपका doubt था? You had asked me about that clearances in the. Kevu, are you there? Fine. We'll go ahead. Satish, have you understood that? Is my voice reachable to you?
Yes, sir.
Okay. So see, this is very important because they do not talk about this new design much. Okay. Why I don't know, they don't talk about in the textbooks is beyond me. Actually, the thing is that all these textbooks are pretty old. Okay. So see, there is an advantage of the fork design over this thing. See, one advantage of the fork design arrangement of the tiller arm is that overall length of the pairs of the rams is reduced. So you do not require that much long arms. Okay, compared to round arm tiller design, which can be important consideration in some cases. A disadvantage is there that any slight misalignment in the case of the round tiller arm is not vitally important. So it could lead to uneven loading of the civil blocks and the fork tiller design, and it is essential that the line of the ramp be exactly at right angles to the rudder stock center line if to avoid it. That means what they're saying is that this fork tiller design can take little bit of what you call misalignment, but that round design where you had got a crosshead will require the centering to be perfect. Okay. Now the other design is here where you have got two what you call ram actuator power units. Okay. Here you have got one power unit. This is other type of design. Okay. Again, this is a ram and cylinder, but here this is not called as a 2 ram or 4 ram. This is called as an actuator type. Okay. So here we have got 2 actuator type, and previously we saw was the 4 actuator type. Okay. So this system differs from the usual hydraulic ram system in that a cylinder is often double acting and that they are not fixed down to the bed plate. That means the cylinder is double acting and they are not connected to the bed plate. That means this entire thing will be moving left and right as required. It is not connected to the bed plate. They are able to move in the spherical bearing, but we have here at both ends of the reams in the ending, okay, to allow this movement. So that means this entire spherical bearing is there and it allows it for the movement. It means basically as the rudder will move in the port or starboard direction, this entire actuator can actually move free to move along the spherical bearing as required. Okay? So that is the advantage of this type of this thing. But this is again for smaller vessels. This is again different what you call photograph of the same thing. So what you have got the same thing, the floating lever and everything which is there. Again, here you've got the emergency hand control lever, and then you've got the same pump stroke lever. As you see, is one pump stroke lever connected to both the pumps. Okay, and similarly, it can operate both the pumps or one pump as required. And then this is the feedback lever, and this is the return lever from the rudder linkage, and this is the feedback lever giving to the angle indicator. ठीक है. तो ये वाला actuator mechanism is also a older mechanism which is no longer there. ठीक है. Now, two ram actuator steering gear. Important point includes self-aligning spherical bearings are used. These eliminate the need for fitted and machine bed plates. Adjustable rudder stops on cylinder ends remove the need for external rudder stops. Basically, you can move the adjustable rudder stop as required. So fixed rudder stop is not required. Okay? Either on the rudder or rudder actuator, that is on the rams. The cylinder require flexible oil hoses to be used. See, all these oil hoses, they are flexible. Okay? All these oil hosing on, because see, the entire cylinders are now able to move. So you require flexible oil hoses connected to the cylinders. Double acting cylinders allow the system to continue operating in event of a failed hose of ram. With double acting cylinder, so even one of the cylinders fails, the other one can take over and operate in one direction at least. The layout can be altered to allow low fitting of steering compartment for any limited space. That means if you do not have a height or width as required, you can have this entire arrangement of a narrow mechanism. It can be narrower place. Okay. So this, what you see here, is a sorry, just give me a second. What you see here is a 4 amp steering gear control system showing the telemotor receiver up here, and then you have the pump control lever, and this is the feedback lever. Again, this is just a line diagram showing the entire thing, and then what you have on top is a control system by hand control. This shown emergency control system by again by a hand pump to actuate the system if the everything fails. You have a hand control system to control the pneumatic system. Okay, hydraulic system. Sorry, you've got relief valves over here. You've got stop valves over here, and again there is a relief valve and there is a bypass valve over here, and a bypass valve over here, and a relief valve in the entire system. Now this is again a line schedule. You will see the entire actual diagrams later on. Okay, when we see the control systems, we'll see the RAM system diagrams later on. Let's start with the rotary vane system now, and then we will go ahead. Just give me a second. Right. So here is a rotary vane system, just shown as the principle of it. So what are the parts? Let's just see about it, okay, before understanding the entire system. Here you have got a ring. You got two rings actually. One is the inlet ring and one is the outlet ring. Okay. So you see oil is coming in here, and they've got three outlets, inlets. Okay. One going into cylinder space number 6, one going into cylinder space number 4, one going into cylinder space number 3. Okay. Right. Then there is a outlet ring, one connected to 7, okay, 5, and 4. Okay, like that. So this is, you got three chambers on each side, all right. And here, what you have in the center is the rudder stop. Connected to it is the rotor number 3, okay, or what they're calling it as a vane boss. Okay. which is keyed. There is a key to the vane boss, or which is the rotor, and connected to the rotors, what you see number 4 are the rotary vanes. You've got 3 rotary vanes over here. Now, how these rotary vanes are also connected, we'll see later on. But assume that they are not one piece. It's not a casting or anything. So these vanes are again connected to the rotary vane by uh, countersunk bolts and pins. We'll see that later on. Okay, and then what you have here, which you see number 5. Okay, 5, this and this. These 3 are your stators, okay, or your fixed twins, okay. The stator or fixed twin is this number 5, which you see here, right? And then you have got chambers which are shown there. One is having the inlet pressure, one is having the outlet pressure. That okay. So and you've got basically the entire ring is correlating the pressures together in the different side of the pressure chambers. Okay, and the entire thing is called as the pressure manifold, inlet pressure manifold or outlet pressure manifold. As the system is there. Okay, so what actually rotates is the rotor, this rotary vane, sorry, the vane boss, along with the rotary vanes rotate, and they will give it the action to the maximum angle of the stator. Whatever is the maximum angle between the stator, they will operate that way. Okay. Now the rudder stalk is tapered in way of the rotor, which is keyed to it. Similar as you had the tiller, which was keyed to your in ram type of steering gear. The stator is secured to the shift structure to prevent rotating. Between the stator or the fixed vanes is connected to the entire shift structure to prevent it from rotation. We'll see how it is connected. Okay. Now, in the annular space between the rotor and the stator are fixed vanes located equidistantly around the inside of the stator. That means this angle between these 3 is equidistant. Okay, that is the idea. Now, located equidistantly around outside the rotor are also equidistant rotary vanes. This combination forms 2 sets of alternative pressure chambers. Each is connected hydraulically to the manifold. Fluid is delivered under pressure to either of these pressure chambers, thus turning the rudder. That means it is turning either clockwise or anti-clockwise as required. Okay. Now, normally the unit is fitted with 3 rotary and 3 fixed vanes, which permits a working rudder angle of 70 degrees. Example, 35 degrees forward to 35 degrees south. The vanes also act as rudder stops, allowing the maximum angle of 80 degrees. So that means the angle between this one stator to the other stator is around 80 degrees, and it allows a 70-degree freedom of movement. Okay, 70-degree freedom of movement means basically 10 degrees बीच में आपका जो स्टेटर रोटर का जो थिकनेस वो भी है इनवर्ट. ठीक है. With specially large rudders are required, only 2 moving and 2 fixed vanes are kept, thus permitting a rudder angle of 130 degrees. So basically, with large rudders, you can have a 130-degree angle on one side. Okay, total movement is 130 degrees. Okay, so that means it can go again 10 degrees in middle, so 130 minus 10 becomes 120. So about on both sides, 60 degrees it can go. Okay, for large type of rudders with 2 rotor vanes. So basically, if you've got 2 rotors and 2 stators, you can get more degree of more movement. Okay, that is the basic idea.
So, sir, what you told, sir, 130 degree?
See, in the way you got, idea क्या है देखो, ये आपका total 360 degree movement है, total possible है, ठीक है? तो
yes, sir.
में से if I remove 10, 10 and 10, ठीक है? So 360 minus 30 is 330.
3. Yes, sir.
330 divided by 3, ठीक है? That gives 110 between all of the rotors, ठीक है? And they are saying it is only possible 35 degrees one side to 35 degrees one side. ठीक है? तो 110 में से 70 degrees निकाल लो, ठीक है? 70 degrees तो बचा कितना 40 degrees. So this 40 degrees means 20 degrees is the stator का thickness over here. ठीक है? So if I want to draw it, just give me a second. Actually, I have a better image. One second. So see here, okay. So here I will annotate in a better fashion. This is again the 3 rotor and 3 stator वाला आपका design, ठीक है? So the angle between this radial angle, one second, let me take a different color. This radial angle, that means between the two ends of the uh, stator is 10 degrees. Suppose this entire thing is 10 degrees, okay? And this now angle of the entire stator, which is in green color, this angle is around 40 degrees. So 40 plus 150, okay? 50 degrees is the mechanical thing that requires it for movement, okay? And now 50 degrees में से आपका जो 120 degrees जो एक साइड में मिलता है, ठीक है? That means now total movement area for between this rudder to move is 70 degrees, ठीक है? Actually not like this, sorry, this one, sorry, this angle is 70 degrees, right? 70 degrees area, so 70 plus 10 plus 40, that means around 140, 120 degrees. So basically, idea kya hai, if you've got 3 of these angles like this, like 3 rotors and 3 stators, you can only give 70-degree movement of the rudder fully to one side. But if you have got only 2, okay, then more amount of angle can be movement, because now the design of the stator, the minimum thickness is obviously going to be the same. Okay, so you can get more angle movement in that. That is the reason you can have, as I say here, when you have got 3 such rotary vanes, okay, 3 rotors and 3 stators, maximum angle on each side is 35, 35. For 70 degrees, your entire vane can move one full direction. But if you have got only 2 rotary vanes, okay, like this, I'll show you what I mean by 2 rotary vanes. So here you have got only 2 rotary vanes. Okay. So 2 rotary vanes is, now you get more angles, no, for the rudder to move. Have you understood what I'm trying to say?
Yes, sir. Yes, sir.
Because see, one more rotary vane is good. So we can see there is certain amount of thickness for the rotor, as well for the stator as well as rotor. So rotor का अगर 10-10 degree पकड़ ले, in this case see what happens. You got 180 degrees between each side. 180 180, ठीक है? 180 में से 180 में से अगर आपने 5 डिग्री निकाल दिया, ये इसका थिकनेस 5 डिग्री इसका निकाल दिया on one side, and say 20 degrees on this, from this to here, from midship to this maximum angle is 20 degrees. So 180 minus 5, minus 25 basically. 180 minus 25, that means 155 degrees total electric movement, divided by 2. That means around 155 divided by 2, that means basically around 77.5 degrees it can move from each side. So have you understood what I'm trying to say? So basically you've got 77 degrees, 75 degrees on this side, 75 degrees on each this side. Then you've got 20 degrees thickness of the stator, then about 5 degrees thickness of the rotor, and again 5 degrees of the, and again 70 degrees on both sides. So that's why sometimes surveyors ask that if you have got a rotary vane steering gear, what is the maximum angle of the movement? Okay, maximum angle possible. So in that case, depends on how many number of rotors and how many number of stators you have. If you have an arrangement where you have got 3 rotors and 3 stators, okay, so that will take up the thickness of the radial angle, okay. So each compartment will be maximum 120 degrees possible, and 120 degree possible, and you got some thickness for the rotor, some thickness for the stator also, okay. So that will take care of that. So maximum angle possible will be maybe 70 degrees. That means 35 degrees, 35 degrees on each side, okay. But if you have got only 2 systems like this, then maximum angle possible can be more, okay. That is the basic idea. Just give me a second. From one rotary wheel steering gear. So you see here what is saying. Maximum angle electrical is 36 into 2. Okay. Over here, all right, because the diameter might be small. Okay, but in a different steering gears, you can have larger diameters of the rudder angle also. I'll show you the larger one. 1 second. See, this is having the 3 stators and 3 rotors. Okay, so here the angle might be less. Okay, but in this design, you see here, this design, you got only 2 rotors and 2 stators. So more number of angle could be there. Okay. This again, we see this diagram when we talk about the hydraulic circuits, how exactly the circuits work. You will see about that. Just give me a second.
Sir,
हाँ जी बोलिए.
can you also take the topic where sometimes they ask कि let कुछ steering gear में and rudder में कुछ problem हो गया है and you have to lock it hydraulically.
बात करेंगे हम लोग. When we come to the hydraulic circuits, we talk about locking कैसा करता है, mechanical locking and hydraulic locking क्या होता है.
Okay, sir.
They discuss that hydraulic locking and because see they talk about hydraulic locking of the steering gears. So there are 2 things to that. There is one thing called as the actual hydraulic locking and there is a hydraulic locking alarm. ठीक है, hydraulic locking alarm क्या होता है वो भी हमको discuss करना पड़ेगा when we see the circuit diagrams. Where was I? Yes. So as I was explaining that you can have, if you've got more number of all right. If you've got more number of rotors, okay, so your angle of your operation can be limited. But if you've got lesser number of your rotor and stator, your angle can be more, as you see here. Okay. So maximum working angle can be 70 degrees, that means 35 on port and starboard. But large rudders, we can have only 2 moving and 2 fixed vanes. So permitted angle is 130 degrees. Okay. Now, the pump delivering the hydraulic medium is driven by a continuous running electric motor. Duplicate motors and pumps are normally provided for one side being on a standby duty, except in the narrow waters, means shallow waters. These are not narrow waters, shallow waters, where you require both of the motors to be operating together. Okay. As a protection against overload, relief valves are connected hydraulically to the 2 manifolds. These are set to lift at a predetermined pressure and safeguard the hydraulic system in event of rudder encountering an abnormally high resistance. Okay. Bypassing of the fluid, allowing the lifting of the relief valve permits the rotor to turn. Sorry. In passenger ships, in emergency steering gear is not fitted. The rotary vane is supplied with dual pressure chambers as being an equivalent of 4 amps. That means both sides double acting can be there. Okay, both the sides can be done. What we saw previously, here only one side can be acted together. Okay, so if you have another pressure manifold connected by another what you call hydraulic circuit, which connects both of the sides together. Okay, so you can have them double acting also. That means oil coming in and oil going out also together. Here you only one side is single acting, what has been shown here. Okay. All right. So you see, this is one for a passenger vessel. One control system is there. All right. What you have here is the rotary vane steering gear in the center, and you have got these large brackets. Okay. These large brackets are connected by some pins. You'll see this arrangement later on, just after this, how that system is there. But what exactly is there over here? We'll just see. You have got the vane unit in the center, port and starboard power units here. 2 is the this thing, and 3 is the motors. 3 is the motor what you have. Okay. Then 4 is the converter basically over here. All right. 4 is the converter which is converting the uh, control button for electronic control or for control system from going from the bridge control. Okay. Which is not yet shown here. Okay. यहाँ पे इसमें दिखाया नहीं है ठीक तरह से. Okay. Then we'll see this when we see the emergency control, no? How that emergency control is there in the actual systems. उसमें आपको दिख जाएगा कि वो what is that push button control and this thing. Hunting motor 1 and 2, okay, is number 6, okay. This is hunting gear control, okay, which is 2 motors connected by. This is that push button control and that one control which is there for the steering gear directly connected from the bridge. This is operating. This is the push button control. You want to operate it by push button. Okay. Emergency local control hand wheel. This one. So once you connect this, this will be disconnected from the telemotor motors over here, and then motor starters, and then check valves are there in the line to allow the uh, excess pressure to be moving only in one direction of the system. Okay, and then bridge steering column is the entire thing that is shown here. Okay, so yeah, again as a diagrammatic representation, we'll see the exact line diagrams later on. Okay. Now, rotary vane power units, main construction details. The rudder stock is tapered in way of the rotor, which is then keyed onto it. Okay. Now, the keyed could be there, could not be there. Again, depends on the type of the arrangement which is there. Need not be always keyed. There could be a hydraulic arrangement also where it is mounted onto that, or there could be hydraulic along with keyed, or without the hydraulic arrangement also. That means there could be mechanical keying also there with a large nut on top. The stator is secured to the ship structure to prevent it from rotating, but it is left with some movement in the vertical direction to account for the rudder carrier wear down and the rudder jumping. Both of them are allowed certain amount of clearance is there. We'll see this clearance, how that is there, where it is there. In the space between the stator and rotor are fixed vanes attached to the stator and the rotating vanes attached to the rotor. Okay. The combination forms two sets of alternative pressure chambers. Each is connected hydraulically to the manifold. Fluid is delivered under pressure to either of these pressure chambers, and it's turning the rudder. Okay. See, how is this connection between the rotor and the stator, the fixed and the moving vanes? I'll just show you. Just give me a second. So you see, this is the rotor. Along with the rotor, this is the rotary vane which you're having here. This is the forward side of the rotary vane. Here there is an internal hole, and there is a countersunk bolt. Okay, this countersunk bolt is a hexagonal what do you call key arrangement type of a bolt with a hex key. Okay, hex head, and it is countersunk. Now that is connected to the entire what do you call rotor. Okay, the rotor is connected that way, and the bolts is there. Along with bolts, there will be also some dowel pins. The dowel pins will be there inside the rotor to align the rotary vane along with it. Okay, and along with the bolts, along with the dowel pins, both of them are connected that way. Okay. Now on the edges of the rotary vane, you have got these seals. Okay, these are rubber seals which are connected to the rotary vane, and the rotary vane is then pushed against the stator chamber. Okay, and basically forming two pressure chambers on the left and the right of it. Okay, that is the idea. Similar construction is of the stator. What is there? The stator is then keyed. First, it is keyed to the what you call the stator chamber. Okay, and again there is bolts coming from outside. There are bolts that are coming from outside which are connected there. Okay. This is again how the rotor and the stator are connected. Again, there will be some dowel pins over there, and there is some arrangement like that similar for the rotor as it is there for the stator. Okay. Just give me a second. All right. Now we'll talk about the further construction of this. Just give me a second. So again, the space between the rotor and stator are fitted vanes attached to the stator, and the rotating vanes attached to the rotor, as I showed you. The combination forms two sets of alternative pressure chambers. Each is connected hydraulically to the manifold. Fluid is delivered under pressure in either of these pressure chambers, thus turning the rotor. Okay. Usually designed as a three-vane design, giving 70-degree total rudder angle movement. Although two rudder vane systems allow a greater rudder angle to be used. Okay, two vane gives more, three vane gives less. If you've got a four vane, it will give further less. Okay. Now the vanes are made of spherical cast iron and are secured to the rotor and stator by dowel pins and keys. Through the modern units can be machined in one piece also. modern mills can be used in one piece, that you can have it the entire thing, machined that way, and but that becomes a very expensive the proposition. That means you have the entire thing machined in a CNC lathe that way. Okay? But it becomes much more rigid in that manner. Okay? The vanes act as rudder stops, okay, and the sealing strips of steel and synthetic rubber are fitted along with the working faces of the vanes. The rudder carrier bearings are usually an integral part of the rotary vane equipment, and the secondary rotary vane unit can be fitted on top of the first to give a backup system in the event of failure. That means you can have a unit like this, one rotary vane on top, one on the bottom, to give an additional system. But I have never encountered this type of system even in some designs. But they are saying it can give that if it is required. But generally, you have only one rotary vane system, and what they do is duplication of the entire सीलिंग सिस्टम ठीक है उसका पूरा चेंबर को सीलिंग को डबल कर देते हैं एंड दे आल्सो डबल अप द एंटायर व्हाट यू कॉल लाइन सिस्टम्स ठीक है तो फॉर गिविंग द डबलिंग ऑफ द सिस्टम्स ठीक है तो ये देखिए ऐसा सिस्टम दिखाया हुआ है एक साइड पे इनलेट है एक साइड पे आउटलेट है कनेक्टेड टू टू एंड दिस इज द रोटर चेंबर ठीक है what they have not shown over here is the status okay what they have not shown is the status actually they have shown the green status sorry it's not like this status are a little bit much more robust as you saw in the first diagram. Stator is not just a small green thing like this. Stator has to be a little bit much more robust to take the entire load of it. Okay? So rotor and stator are not directly like this. You can let me just show you a better diagram of this. Just give me a second. See, this is a better diagram of the same thing. See, the rotors are like this, all right, and this is the status. Okay, so this is how it is moving, and the rotors are much more thicker as you see here. The stator is thinner in proportion. They are not more like this in that uniform direction. Okay. So there is a ceiling. See, one more thing is there. When you talk about the ceilings in the systems, there is a ceiling ring which is going rotation full 360-degree along the circumference of the entire rotor on the top. Okay, we'll see this when you see the diagram of the system. No, there actually I can show it right now also. See here, what you see here. This is the ceiling which is there on the top of the rotor. Okay, and in the top of the stator. Along with the edges which are there, they are having ceilings over there as well as on the edges of the system. I just show you that diagram. So actually, कैसा ना, I'll show you in the line diagram we study. No, you'll see that entire cross section of the system there. Okay, we talk about it then. So here we have the parts of it. Rudder stroke is E. What you see here, cast steel rotor key to the rudder stroke. Okay, this one E. Along with that, your steering gear, iron rotor vanes, cast iron rotor vanes. Entire thing is cast iron. Okay. Keyed and doweled to the rotor. As I said, there is a dowel beam arrangement, and then there is keying also of the rotor. Okay. Cast steel stator back to the ship structure. This entire stator is there. It will be connected to the ship structure. Steering gear iron stator vanes are keyed and doweled to the stator. These are also keyed and doweled. You see here, right? Okay, synthetic rubber strips backed with steel strips. Okay, steel strip is on the back and synthetic rubber in front to give the sealing of it on the rotor as well as on the stator head. Means rotor पे यहाँ पे बाहर में, stator में अंदर side sealing is there. Now this is the entire holding down arrangement of the rotor to the ship's hull. Okay. So what you see here, this is the stator in outwards, and in the center you have the rotor. Okay. What you see here, this is the E is the fixed vane, this is the stator, and what you see here outward is the number D is the rotary vane or moving vane. So moving vane has got these countersunk holes as you see, which are connected over here, and the fixed vanes you see here is bolted from outside the stator chamber. The stator chamber के बाहर से इसको bolt कर रहा है. and the moving vanes has got the sealing strip over here in the center, and the fixed vanes have got the sealing strip in the center outwards here, in the inwards. Okay. The moving vane has got it in inwards. Moving vane has got the outward sealing strip. The fixed vane has got an inward facing sealing strip against the rotor. Okay. That is the idea. Now, this is how the entire arrangement is joined to the hull. Okay. So see, there is a these boards. Okay, these boards are connecting the entire arrangements. This IL, this is a anchor bracket. Anchor bracket is connected to the ship's hull. Connected to the anchor brackets is a pair of anchor pins. Okay. Now this arrangement is for a naval warship uh, rotary vane. You could have a two-pin arrangement like this, two anchor pin arrangement like this, or you can have a different arrangement also. I'll show you the modern one. Okay, you do not have only two pins. You can have a full bolting system arrangement also. This is the older mechanism where you've got a two-pin anchor pin arrangement like that. Okay. Uh, and this is a better diagram of the same. So what you have here, rotor and stator, वो तो पहले ही आ गया. But what you have here in the center is this entire thing is connected to the stator, this entire housing, and here you have rubber, which is again a shock absorber connected to the both sides of the anchor pin. Okay, this is the anchor pin, anchor bolt, which is this is anchor pin in the center, and outward is the anchor bolt, which is tightened. So you have got a nut on top and a nut on below, and you're tightening it from both ends, and you are effectively uh, connecting this stator to the vessel by the anchor bracket through the anchor bolts. Okay. Now this rubber shock absorber shocks serves as a to limit the what you call shocks from the movement of the as the rudder is being moving. It will transmit some shock, and that will be absorbed by this rudder shock absorber. This rudder is the shock absorber is also rubber, but it can also be of an epoxy design. You can have it filled with in a liquid state, and it will solidify, and it will give the rubber it will fill the entire thing as you do a chalk casting. But now it is not a rigid thing; it is a soft absorbent thing. It cannot that way. It can be put in position or something like that. You read about this. The rotor vanes are normally of spherical cast iron are secured to the rotor by countersunk cap screws, strengthened by maintained by full length key and keyway to the vane. The stator is normally cast keys, and vanes are secured by countersunk cap screws and by high tensile dowel pins. The large circumference of the rotor allows for the use of the dowel pins as opposed to keys. You can put keys, dowel pins in the of the rotor. Now, rotation and the stator is prevented by means of two anchor brackets and two anchor bolts. The anchor brackets are secured and bolted to the stool, basically where it is mounted onto the on the steering platform. And the vertical clearance is arranged inside side of the stator flanges and top and bottom of the anchor brackets to allow for a vertical movement of the rudder stop. Basically, this there is some amount of clearance over here between the anchor bracket and this entire top flange of the stator, and between the bottom flange of the anchor bracket and the bottom flange of the anchor bracket. Basically, there is some clearance over there. Okay. Now, the clearance varies with each size of rotary vane, but unit could be about 40 millimeter in total. It is essential that the rudder carrier should be capable of restricting the vertical movement of the rudder stop to less than this amount. That means whatever the total amount of the movement, 40 millimeters से कम हो. Either the vertical movement upwards or the wear down of the rotary vane the bearing which is down here downwards. As I discussed previously that there is a thrust spring in this rotary vane which takes care and a taper which allows for the non design of the rudder carrier bearing. But certain types of rudder carrier bearings are there even in rotary vane units, like you see here. Okay. And in this design, what you have seen here, where a stator is there on top and you've got a rudder stop, here you also have a rudder carrier. You could have many of these rotary vane units without any rudder carrier. But again, some design are there along with rudder carrier. But the design is such that now there is a bear down clearance which is on again given on top, okay, and a bumping clearance or a jumping clearance is there on the bottom, and total top and bottom clearances मिला के होता है around 40 millimeters. ठीक है, generally it is around maybe about 15 millimeters on the bottom or 10 millimeters on the bottom and around 35 millimeter or 25 millimeters on top. ठीक है, so total 40 millimeters का होगा between the anchor bracket which is this one connected to the ship's bolting system or the stator which is this thing. Okay, so there could be arrangement with a separate rudder carrier bearing on bottom, or there could be arrangement inside this only. There could be a thrust ring and a vertical ring which is there, so no need to a separate rudder carrier bearing over there. Okay, so depend on the design. You could have a separate rudder carrier bearing without any bearing material in the rotary vane, or in the rotary vane also they could incorporate a bearing which is there, okay, on the lower side of the rotary vane, of the lower side of the rotor. Okay, they could have a bearing over there. So either case, the vertical clearance is such that the lower one is the jumping clearance, and the vertical upper one is the wear down clearance, similar to the one which we saw where you had got the two fork type of the tiller which we had, or the two ram steering here. इसका भी वैसा ही design. Just give me a second. Okay, is that okay? We can go ahead and we can talk about the last part in this design before we have yet to talk about your quad layout control systems. But what we have last is the mechanical advantage. Okay, we talk about the mechanical advantage, how to calculate mechanical advantage, because sometimes they ask what is mechanical advantage of your steering gear. Okay, so that will be uniform as per the design of the steering gear. We'll just see again. So we have discussed the three systems which we have discussed now. We have seen the RAM type with the Rapson slide and the rotary vane type and the pinch actuator mechanism. Three you have discussed till now. Okay. So we have discussed this previously, that the two designs of the RAM type Rapson slide, either the corset type or one with the forked tiller. Okay. Either tiller is round or the tiller is forked. Okay. In this case, the rams are forked. In this case, the ram is uniform cross section. So when you talk about Rapson slide mechanism, you got two designs: fork tiller mechanism and round tiller type. Okay. So this is the fork tiller type, the normal ships which we have. A two ram steering gear is shown here. Okay. So a diagrammatical representation there. Diagrammatical representation is the ram which is there and the cylinder which is there, and you have got the fork tiller in the middle. Now the fork tillers, the thrust from the ram is only transmitted to the tiller through the swivel blocks, as we saw in the diagram. Okay. Now the advantage of this is that overall length of the pair of rams is reduced compared to the round ram tiller design. There is also a disadvantage that if there is any misalignment, it could lead to uneven loading of swivel blocks, and there could be bad effects, and therefore absolutely essential to have center line of the rams exactly right angles to the cylinder. That means you need to have this exactly perpendicular in the midship position. So that means misalignment cannot be taken care in this fork tiller mechanism. Okay, because here you have got the clearances have to be very perfect. Now this is a round arm tiller design where you got a double acting 4 ram steering gear or 4 cylinder 2 ram steering gear. Okay, here is the center rudder stop in the center. Okay, both of them are the Rapson slide mechanism. Okay, here you have got a double bearing arrangement on the side to allow the movement on both sides. You've got two bearings and you've got a central crosset, large crosset design which is on. Okay. Now, if the round tiller arm type, each pair of rams is coupled together to form a bearing in which the trunnion arms of the entire crosset, thus the straight line effort of the rams gives the circular movement of the crosset. And the slight misalignments are not that important. That means you can take certain amount of misalignment in this design. Okay, you do not have to worry about the misalignment that much in this design, where you put the round what do you call tiller, solid tiller, and you have the forked rams in this case. Okay. The Rapson's guide mechanism is stated earlier the most popular for high duty gears, steering gears, because the torque generated increases as per the rudder angle increases. Okay. So to understand this, you just see you see this angle theta is the angle of the maximum angle movement of the rudder, and the same thing can be shown over here as per the angle which the rudder will move. The rudder angle which the actuators move, the same angle as the rudder moves. Okay. So P is the oil pressure acting on the ram, as you see here. Okay. A is the cross-sectional area, that means the cross-sectional area of the ram. Okay. N is number of rams which the pressure is acting. That means you've got two rams, N is two. If you've got four rams, then you've got N is four. And R is the radius of the tiller. That means the entire distance is the R, the radius of the length of the tiller. Basically, the length of the distance between the rudder stalk and the tiller center, the crosshead center, basically. Okay, in this design. So the torque reaction from the rudder is taken on the tiller by a force which is balanced by an equal and opposite force having two components. One of which is produced by the ram and acts in the line of the ram, and while the other is at right angles to the line of the ram and is produced by a guide reaction, as shown here. This is the guide reaction. Okay. So one is this, and one is this distance. Okay. So basically, though components, but it has been two components is broken into. Okay. So if the guides are not fitted in such a small steering gear, then the guide reaction force to be carried on the bearing of the guides is has to be carried by the bearing. So it is not almost negligible in that. In case we show the reaction by a vector diagram you see here, rudder reaction is PA cos theta, basically PA into the cos of this angle, basically this angle is 1. And from the movement we can get effective tiller length with R cos theta. Okay, so effectively you have P R into N, basically the rudder reaction into effective length with number of rams. Okay, and you're not talking about the area. Area is also to be added over here. A basically you've got to because the torque measure will be PARN. Okay, so that is basically PA is the rudder reaction they were added over here. P is the pressure, A is the area cross sectional area, R is the length, and N is the number of runs, which is now in the vectors is PA by cos theta, R by cos theta, N is the number of runs. So basically this becomes torque is equal to PARN by cos square theta. So basically 1 by cos square theta is the mechanical advantage. Okay, which is always greater than 1 for this type of gears. तो अगर ये maximum angle आपका 35 degrees है, this becomes something like 1.22 I believe. Let me just do cos say 35 cos 35. So 1 answer square. So 0.9 1 divided by answer. So it becomes 1.1 1.2 or something mechanical advantage. So maximum angle 35 degrees. The mechanical advantage because we have 1.2, 1.15, somewhere as per the angle of this thing. So this is the mechanical advantage for the Rapson slide type of the steering gears. Okay, so the ram type steering gears basically. Now for the rotary vane mechanism, the rotary vane mechanism produces torque which is directly proportional to the hydraulic pressure in the steering gears. Basically, whatever the steering gear, uske directly proportional hota. So torque is equal to pressure into area of the rotor vane into number of rotary vanes into radius of the vanes. That becomes basically here you do not have any variation. Like you had a rudder reaction which is there at a different angle. यहाँ पे वो नहीं है, यहाँ पे direct correlation. So that's why this is because of PARN. So that's why you will divide it in the same format. Like you had your PARN by 1 by cos square theta, which is the mechanical advantage. Here the mechanical advantage is 1. So this, the mechanical advantage being 1, has got a lesser efficiency than that one. So that means torque over here will be much more in the same size if you have the same pressure, same cross-sectional area of this thing. Okay, is the same. So that's why this one has got a lesser mechanical advantage than that. Okay, mechanical advantage therefore 1. So that one is better, higher mechanical advantage. That's why the ram type steering gear is much more popular than the rotary vane steering. Now, similar talking about the rudder actuator mechanism, pinned one. The steering gear, the system is a double acting pinned rotor mechanism as shown below. they are more compact in the absence guide mechanism. They do not produce a mechanical advantage greater than 1, but at rudder angle of 35, the mechanical advantage is about 0.8 in this designs. Okay. So again, the mechanical advantage is about 0.8. So it is not more than your rotary vane, lesser than the rotary vane, but much lesser than your absence guide mechanism. So that's why you always have the absence guide mechanism where your mechanical advantage is more. So basically, as the rudder angle increase, the torque for the uh, actuating system, that means the power pumps, everything reduces. Okay. Here, the torque applied for the rudder stop varies with the angle deflection on the location of the actuator. Means as I remember that this is a pin when we can go either upward or downward depending on the angle of the rudder. Therefore, torque is equal to hydraulic force into effective rudder tiller length. So PA n into cos phi theta by plus or minus theta. Okay, minus 5. 5 is the angle of the cylinder with the what is the maximum angle of the deviation of the rudder, different angle, and theta is the angle of the maximum angle rudder angle. So you remember in your or your ram type steering gear, there was no theta and there was no phi. There was no phi basically. Theta was there as the same, but here there is a deviation and the phi is there. So that basically your hydraulic force is into effective tiller length is the PA into cos theta plus or minus 5, depending on whether it is above or below. So again, maximum in the maximum 35-degree angle, the mechanical advantage in this is about 0.8. So lesser mechanical advantage, but it is much more compact arrangement. So you can get saving of space in this type of arrangement, and you can have better weight to saving ratio on the sticker. Okay, I see that. Just give me a second.